Okay, we're going to do some analysis of something called the Pythagorean Theorem, which is actually a very well-known and typically liked theorem amongst non-mathematicians. So that's nice. Lots of times mathematics gets a bad rap, but people seem to like and remember the Pythagorean Theorem. So it's pretty fascinating. Most people remember it as a squared plus b squared plus c squared, but that's only useful if you remember what a, b, and c are. And you might, but it applies to right triangles only to right triangles. So it says if we have a right triangle, meaning a 90-degree angle in a triangle, if we have a right triangle, then the following is true. So in a right triangle, the side opposite the 90-degree angle is called a hypotenuse. And then the other two sides are called legs. Doesn't matter which one is which, they're just both legs. So the Pythagorean theorem says if we have a right triangle, then the following equation is true. The sum of the squares of the legs, so leg squared plus the other leg squared, equals the hypotenuse squared. Okay, so that's the Pythagorean theorem. Again, typically remembered as a squared plus b squared equals c squared, where a and b are the legs and c is the hypotenuse. So how do you solve for the hypotenuse? So if you solve this equation for the hypotenuse, then you would simply take the square root of both sides, and you have the square root of the sum of the legs squared. The sum of the squares of the legs. Okay, you square each leg, add those together, and then take the square root. Don't forget to take the square root. If you wanted to solve for a leg, how would you do that? Well, you would have to subtract, say we want to solve for this leg, you would have to subtract this guy, right? So what that looks like is you'll have hypotenuse squared minus this other leg squared, and then square root both sides to get rid of the square on the leg. So the idea is if you want to ever get the hypotenuse, you add. The hypotenuse is the biggest side, so you add the two other sides. If you ever want to find one of the shorter sides, you have to subtract. Okay, so you take the biggest side, the hypotenuse, minus the other side. And those are squares because of the Pythagorean theorem relationship. And then the square root is what a lot of people forget. So let's practice finding the third side of some right triangles. So several examples here. So find the missing side. I should say determine the length of the missing side, but I'll keep it short here. So we'll start with something like this. Let's say that this is 3 and 4. It's a right triangle. Let's do another one. A right triangle. Let's say that this is 26 and this guy here is 24. And we'll do one more. Let's say that this guy is 7 and this guy is 11. Okay? So, if I want to find the missing side here, that's the hypotenuse. So that means I'll have to add the squares of these, so 4 squared plus 3 squared, but then take the square root. So that's the square root of 16 plus 9, which is 25, which means the missing side length is 5. Okay, that came out nice. In fact, that one's so well known, it's called a Pythagorean triple. It's called a 3, 4, 5 Pythagorean triple. Actually used in construction quite a bit to get right angles. All right, the next one, we're missing a short side, so now I need to subtract. So I have to square each of these. So 26 squared minus 24 squared, and take the square root. Okay. which is the square root of 100 when you use your calculator, and that happens to turn out to be 10. So again, a very nice answer here. We get 10. Let's do this last example. Here we're missing a leg, so again we have to subtract. So we'll do 11 squared minus 7 squared. So that's 72. And we've got the square root of 72. Now that's not a nice number, so I would prefer just to leave it as the square root of 72. So if you verify this with the Pythagorean theorem, if you square the legs, that's 49. If you square this, you get 72. 49 plus 72 is 121, which is this guy squared. So that's kind of a nice little check there. Now, if you have a calculator, if you want to do this yourself, you can simplify this. I won't go into how, but it turns into, what, 6 square roots of 2, basically pulling out the 36 and taking the square root of that to get 6. So 6 square roots of 2, some calculators will give you that as the answer, or you could simplify it yourself. Or, depending on the scenario, you don't want to do this as your usual habit, but you could take the square root of that and get an approximate answer, which is about 8.5, okay? So that's also useful to know that this side's about 8.5 units long. But the square root answer, in my opinion, is the best here.